A very good morning, guys. This is Anand Kumar. I'm currently working as an assistant professor in the Department of Information Technology in SNS College of Technology. Welcome to my video lecture series number 2. The last class we have seen about React.js basics, and in this class we'll just start with the last class's continuation. That is the recap of what we have seen in the last class. In the last class, we have seen about various stages of design thinking. That is what we call it as empathize, define, ideate, prototype, and testing. So in the empathize part, we have seen about understanding about the user needs. So in the definition part, we have seen about what is React.js and what are the basic components of React.js basics. So in the ideate phase, we have seen about thinking in about the components, and we have seen about the usage of JSX and the virtual DOM, that is document object model. So regarding the prototype, we have seen building a simple React app, that is Hello React. So in the testing and evaluation field, we have seen about what we call as a counter application. And in the conclusion, we have summed up. And from the summing up of the last class, we'll just continue with the document object model. In this class or in this video, we'll be seeing about the document object models, that is what we call as DOM in this chart, various stages of design thinking phase implementation. That is, we'll start with empathize field, that is understanding about the user's challenge. The problem given here, or the problem which faces, is the traditional websites update slowly when DOM changes occur. The user pain points or page reloads causing very poor user experience and the performance drop with frequent user UI updates, and the developers struggle to maintain complex UI states. For example, in a live chat, the the app will be like in a lagging field with every new message. Suppose if one new message comes, the app will be getting lag. So regarding the empathize field, we will start with something called as observing real world scenarios. The users expect instant feedback and smooth iterations. So the developers need the frameworks that reduce manual DOA manipulation. I mean to say, each thing should be implemented in different ways, and each thing should be like invoked in a different stages. So in order to improve app responsiveness, we can use React.js, and regarding the DOM, we can use the simplification component updates. So the observation inside what we have here is users don't care about the DOM, they care about the speed and the smoothness. So in the definition phase, we'll start the defining of the problem statement. That is, how might we make the UI update instantly without reloading or rewriting large parts of the DOM? So in need of the efficient UI rendering, the goal is to achieve improved performance, scalability, and developer experience. So in the definition field, we'll start with React's approach of the virtual DOM, and React introduces virtual DOM as a solution. The definition given here is a lightweight in-memory representation of the real DOM. Working principle, working principle, like React updates the virtual DOM first, then efficiently updates only the changed parts of the real DOM. Benefit, it renders faster and the reflows are very minimal, and the user exchange, that is the smoother user exchange. So coming to the idea phase, we'll compare the ideas of traditional DOM and virtual DOM. So coming to the traditional and the virtual DOM, the aspect traditional DOM and the virtual DOM are compared, right? From the update method, the direct manipulation, and the diffing and batching of algorithms has been dealt with tradition and React virtual. So regarding the performance, traditional is somewhat slower for frequent updates, while the React virtual DOM is faster and optimized. So in the aspect of developer effort, the traditional DOM supports manual thing, while the React virtual DOM supports the automated via React engine. In the aspect of scalability, the traditional DOM is complex, whereas the React virtual DOM modular and reusable components. So considering a prototype phase, function counter, I'll just explain this snippet. The function is declared as counter, and the constant is set to count and set count, and the use state is set to 0. While returning, it will be divided into count and button on click event. While the button on count on click event is set, it will be incrementing. I mean to say, a counter will be incrementing by one click on a click. So, explanation as I told you, each button click updates only the changed value in the virtual DOM, not the entire value will be changed. So the React compares, that is, differentiates old versus new virtual DOM and updates the real DOM efficiently. Coming to the test phase, that is the impact of the testing. The metrics for testing React DOM efficiency is through rendering speed, memory usage, frame rate during updates, and frame rate during the transaction. And the tools we have used is React developer tools. And regarding the tools, another tool we have used is Chrome Performance tab for metric. And the observations what we have got here is React DOM updates faster and consumes less memory than direct DOM operations. So coming to the conclusion and the reflection part, the final insights and the learnings are as follows. React Virtual DOM bridges performance and user satisfaction. Regarding the design thinking implementation and the outcome as concerned, the empathize part is defined to identify the user pain, that is slow user identification, slow UI. And the next is definition part, the need efficient UI rendering, that is the need for efficient UI rendering. And regarding the ID part, it introduces the visual DOM. And to the prototype part, we have built with the React, and we have tested. And we have tested the measure and efficiency of the user exchange improvement. And the final code is React doesn't change the DOM, it changes how we think about it. And with this thing, I'll just end my video here. The remaining things we will see in the video number 3. Thank you.